So in this application exercise, we're going to learn about a technique that uses restriction enzymes and gel electrophoresis to map DNA. The technique is called restriction mapping, and it's a method used to map an unknown segment of DNA by breaking it into pieces and then identifying the locations of those breakpoints. This method relies on the use of restriction enzymes, which we've learned about. And remember, restriction enzymes cut or digest DNA molecules at short, specific sequences called restriction sites. After a DNA segment has been digested using a restriction enzyme, the resulting fragments can be examined using gel electrophoresis, which is going to separate the pieces according to their size. So for this exercise, we're going to use a piece of DNA that's commonly used in molecular biology called a plasmid. Plasmids are small, circular pieces of DNA which are commonly found in bacteria. They are considered extrachromosomal DNA, meaning that they are physically separated from chromosomes and they replicate independently of chromosomes. Plasmids are used a lot in molecular biology as tools to manipulate genes. So we're going to use a plasmid that is 7.5 kilobases in its size. Remember, a base pair is a unit consisting of two nucleobases bound together by hydrogen bonds. You can either have a guanine cytosine base pair, like I've shown in this figure, or you could have adenine thymine base pairs. So what's a kilobase? A kilobase equals 1,000 of these base pairs. So our 7.5 kilobase plasmid has 7,500 base pairs. So our base pairs are arranged in this circular piece of DNA, and this particular plasmid has recognition sites for different restriction enzymes. It has one recognition site for a restriction enzyme called XBA1. It has one recognition site for a different restriction enzyme called AGE1. And what I'd like you to do is to think about what you would predict would happen if you were to digest this plasmid with both XBA1 and AGE1. So they're going to recognize their sites and cleave our DNA. And we know that we have one recognition site for each one of our enzymes. And therefore, we would expect the result of this restriction digest to be two DNA fragments. The sizes of those DNA fragments would be 300 base pairs between the AGE1 restriction site and the XBA1 restriction site. And that would leave a fragment of DNA that is 7.2 kilobase pairs long. So if our plasmid is 7.5 kilobase pairs, and we are going to digest the DNA into two fragments, one is 300 base pairs and the other is 7,200 base pairs, the fragments have to equal the total size of our plasmid. So in this digest, we get one fragment of 300 base pairs and one DNA fragment that's 7,200 base pairs or 7.2 kilobase pairs. And these add up to the total number of base pairs in our original plasmid. In addition to the XBA and AGE1 recognition sites, this plasmid also has two recognition sites for EcoR1, which are shown here. There's one site here and one site here. So digestion with EcoR1 should give us two DNA fragments. One is 2,100 base pairs and the other is 5,400 base pairs. 2,100 plus 5,400 gives us our total base pairs of our original uncut plasmid of 7,500 base pairs. So we could fill out a table and we could analyze the number of bands and their sizes. So in our uncut circular plasmid, if we were to run this on a gel, we would only see one band, and the size should approximately be 7.5 kilobase pairs. If we were to digest the DNA with age 1, it has one recognition site, and that would linearize our circular plasmid and produce a single band of 7.5 kilobases. If we were to cut with the ExPA restriction enzyme, it also has one recognition site. It would result in a linearized plasmid. In other words, it would produce a single band on an agarose gel that should be 7.5 kilobases. EcoR1 has two recognition sites. That means it would cut the plasmid into two separate pieces. The sizes of those pieces would be 2.1 kilobases and 5.4 kilobases, which should add up to the total plasmid size of 7.5 kilobases. If we were to do a restriction digest that combined age 1 and ExPA 1, that would give us a total of two recognition sites. It would produce two bands on our gel, and the size of those bands would be 300 base pairs and 7.2 kilobase pairs, which would add up together to 7.5 kilobase pairs of the intact plasmid. So with that background information, please try the exercise on your own.